All right, I've just started ArcGIS Pro. I installed the patch 3.0.1, so if this looks a little different than yours, that could be why. So I like to start without using a template. This saves me from having a bunch of random geodatabases and stuff created in a project folder that Esri has. The bad news is you have to do a couple of steps of inserting a new map. So if it isn't defaulting to insert, click the insert tab and then new map. All right. I've also set my custom settings to not automatically put a base map in because I don't need one. So I've got a new map and I need to add data. We're going to pull data from ArcGIS Online. So if you aren't sure where that is, your stuff should be organized like this, where you've got your project, the portal, which is where we're going to go, to ArcGIS Online, and then a map to your local files. And let's search for US county data. And then I double check to make sure this is set to relevance. Otherwise, you don't get very useful information. We are going to use these County Health Rankings 2020. So if this doesn't show up on your list, you could also search County Health Rankings and just make sure you're pulling this most recent file. Okay, it adds to the map and doesn't look like much, does it? First of all, clearly have a horrible coordinate system displaying this stuff, but we'll fix that. If you expand this, you can see that it's given to us in 3 levels, 3 aggregation levels. We want to work with the county levels, so we can turn these off, and what you'll see is it disappears because it has a scale set, and it's only going to draw when you're zoomed in enough to see this. Okay, I right-clicked down here and went into the layer properties, and under the general tab is the scaling rules, the visibility range, and I'm just going to get rid of this and set it to none. That way I should be able to zoom out and it's going to maintain drawing it even if we're zoomed out too far. Okay, so then the next thing is it's automatically displaying life expectancy. Let's just see what's going on with this data set. If we right click and open the attribute table. The easiest way to take a look at this sometimes is to open select by attributes, and we want a new selection where the field, and then it shows us all of the fields right here. I think it's kind of a shortcut. So poor physical health, the number of days, percent of the population born with low birth weight, the percent of the population, adult population that smokes, obesity rates, impaired driving. You can see that there's quite a lot in here. Yikes. Okay, that's good news. We have a lot to work with. All right, let me move this over so we can see that going forward. Okay, so what are we going to do here? We don't need county and state. We can kind of collapse those down. And what I want you guys to do is set up some maps playing with this choropleth data. So choose a field. Maybe it's the percent of adults that smoke. You can right click to open the symbology. This data right now is being shown as unclassed, and this is one of the maps that I'd like you to make. So when it's unclassed, ARC is pretty slick in that they show you a histogram of the distribution of this data and shows you, well, actually, I'm not sure what the 80 and 70 represent. It's showing you the mean. I guess it could be with the extremes here. And this would be on a county by county. Some county has a mean life expectancy of 104. I gotta check this out. Okay, I did a little digging, found the life expectancy column, sorted it descending, found the 104, and noticed that there are a whole bunch of counties that have this really high number, I think. I'm not exactly sure what it is, but I thought I would check this out first. And it turns out that it's a county in Colorado. San Miguel County, Colorado. Actually, 3 of the top 5 are in Colorado for high life expectancies. And I thought, well, then what is that number? What does that mean? And it turns out you can go to countyhealthrankings.org and we can explore the health rankings. I just went to this 2022 measures page. And this is basically a description of every single column or variable that they measure. Health outcomes is where I found the life expectancy. And there's about and explore the data, reasons for including it, the key measure methods, the data source, references, how the component fits into the model. Life expectancy is an average. It's the average number of years from birth that a person can expect to live in each county. So I don't know about San Miguel, Colorado and what's going on there, but apparently you can expect to live to 104 years old. So, yeah, so the assignment, what are you going to do? We've got symbology that we need to be working on here. Actually, I'm going to clear my selection and go back in here and open the symbology window. All right. So, and then what I was starting to say earlier is that this is being shown with unclassed colors, and then I went into a very inarticulate tangent about the histogram down here. But you're going to make one map using the unclassed colors, and then I want you to make a series of maps using graduated colors. I want you to experiment with graduated symbols, proportional symbols, yeah, even dot density, frankly. So graduated colors, ARC is going to automatically do 2 things. Number 1, it's going to choose a field for you, and it's going to choose a classification method for you. Actually, it's going to do all sorts of things, because it's also just choosing its own color ramp. And you can see here that the pattern doesn't make any sense for life expectancy. Wow, and that's because it's actually symbolizing based on object ID, which is tied obviously to the state. So the first thing you need to always check whenever you're symbolizing something is what field is being symbolized. And this is where you need to go in and decide what are you going to make your maps about. Whatever you pick, it needs to be the same for every single map you make so that we're actually comparing, you know, apples to apples. We could do excessive drinking. Okay, so this is showing us a color ramp with a predetermined set of class breaks that show up here and over in our, you know, kind of legend. So these don't need to be normalized because it's already a %, so it's been normalized for us. Here is a view using natural breaks. I want you to experiment with the other types, geometric interval. You're going to be comparing both how it looks on the map and where the class breaks are over here. So you're going to need to include a legend for each one of your maps. I'll demonstrate that in a second video. Let's go to like quantile. All right, so like I was saying, you should also mess around with the graduated symbol. The nice thing about graduated symbol is the look of the map according to how big the county is. Big counties are going to get more attention because they're big. The little ones kind of disappear. And so that's a bit of a problem, and that's why I'm going to show you a trick using hexagon maps, which normalizes the area instead of the value. So let's go back to this excessive drinking variable. There it was. All right, one thing I wanted to show you before we move on to the layout instructions or demonstration is, like for the example with our excessive drinking, I definitely want you to explore the classification types here. I want to let you know that this bivariate, we're going to do this a little bit later when we deal with multiple variables. You can definitely experiment. The idea is you can show 2 different variables. So you could show like the percent of excessive drinking relative to the percent of the population that's uninsured or something like that, and make a bivariate map. But we're not going to do that this week because this is a lot about legends, and that's a whole different focus than we're going to work on today. So where was I going with that? Graduated colors over here in the method. So this is the percent of the population that excessively drinks, and these numbers seem a bit high to me, but you know, we can go in and read about how this data is calculated. But what I want to show you is the standard deviation option, because we know that the excessive drinking, we looked at the histogram and saw that it was a normal distribution of values, that the standard deviation is a good one to use for this. And we want this middle class to have a neutral color. And so we'd want to change this to a divergent color ramp, something more like this, where we have this neutral color in the middle, and then we deviate away. These are negative values and these are positive values. And so the white counties are the counties that have values that are very close to the average. And the farther you get away, the darker the color in either direction, are the counties that are very above or below the national mean, which is a really interesting way to show it, I think. You know, the very darkest colors are, you know, like right up here. I wonder what county this is. Use our pop-up. So up in Montana, we have some counties that are well above the mean for excessive drinking. North Dakota, Douglas County, Wisconsin. Actually, a lot of Wisconsin is above the mean. It's got to be the Green Bay Packers. It's because they do a lot of celebrating, I'm sure. And then we've got some, you know, drier states that are well below the mean, and Utah. Okay, so standard deviation, really interesting way, I think, to display data where you're incorporating the idea of where do you sit relative to other people instead of just a value, right? Okay, but again, the divergent color ramp is a critical piece of that, and making sure that your middle class that's close to the mean is truly a neutral color. So I think that's really important here.